Hello everyone. So today we'll be talking about integration. So what is integration? You can consider integration as basically anti-differentiation. So whatever you differentiate, the reverse of that is integration. So let's have a function f of x and let it be equal to 3x squared. Now, if we differentiate this, what we usually do is we bring the power down and it reduces by 1 here. So this is what we'll get. Well, 2 times 3x to the power of 2 minus 1 when we differentiate, and this is equal to 6x. So since we know that integration is basically the reverse of differentiation, we basically do the differentiation steps in the opposite way, like basically the opposite of. So here, the last thing which we did was we subtracted the power by 1. So now here we have the power of x is 1. So if we're doing the reverse, instead of subtracting 1, we add 1 when we integrate. And now the new power becomes 2. Before, in differentiation, we took down the power and multiplied the coefficient with that. But in integration, instead of multiplying, we do the opposite, which is divide. So divide the coefficient by the new power, and you get 6 divided by 2. So that's f of x. And then if you do 6 divided by 2 is 3. And x to the power of 1 plus 1 is x squared. As you see, we're back to our original function, which was f of x is equal to 3x squared. Now, let us do like another one. So let the new function be f of x is equal to 7x cubed plus 2. If we differentiate this, what we get is, so the power comes down and it reduces by 1. So you get 3 times 7x to the power of 3 minus 1 plus, the power also comes down here. So this is meant to be x. Since 2 is by itself, we can add x to the power of 0 to it. X to the power of 0 is 1. So 2 is basically the same as 2x to the power of 0. So if we bring the coefficient down, if we bring the power down, you're basically multiplying the coefficient by 0. So anything multiplied by 0 is 0. So if you differentiate 2, then result is 0. So yeah. So then as our answer, we would then get 21x squared. Now let us now integrate this. So when we integrate this, we add 1 to the power. So that's what we first do, because the last step we did in differentiation was subtract 1. So now we have to add 1 since we're integrating. And then divide the new coefficient by the new power. As like we bring down the power and divide the coefficient by that power. So then we get 21 divided by 3. Then once we solve that, we get 21 divided by 3 is 7, and x to the power of 2 plus 1 is x cubed. But if we look at it, we have 7x cubed here, but our original equation was f of x is equal to 7x cubed plus 2. So that's why when we integrate a function, after integrating, we add a c. The c here represents the constant of integration. It can be any value from like, it can be -1, 2, 3, any real value. In this case, the c may not necessarily be a 2, because there can also be another function like f of x is equal to 7x cubed plus 7. Now if we differentiate that, we would also get 21x squared, which is the same as the one for our other one, which was 7x cubed plus 2. So therefore, when we integrate both of them, that's why we put the plus c, because the c can be either a 2 or can be either a 7. Okay. So now let's talk about how we usually notate integration. So integration is represented by this long S-like symbol. To some of you it may look like an F, but it's more S-like. So if we are integrating, suppose f of x, we have the integral of f of x, and we have dx. This is how we notate integration. So let's do some more problems. So here's one. Okay, so the integral of 5x cubed plus 4 dx. Now we do the same thing, so that's basically 5 x to the power. So first we add 1 to the power, so we get 3 plus 1, and then we divide the coefficient by the new power, and then we get 4. So 5 divided by 4 times x to the power 3 plus 1. Then we do the same thing here for plus 4. It's plus 4 to the 4 times x to the power of 0. So we add 1 to the power. So we add 1 to the power, and then we divide the coefficient by the new power, which is 1, and in the end, this is our answer. So now, like we'll just do another problem just to reinforce the concept. So the integral of, suppose, let's say 6x to the power of 5 plus 7x squared plus 2 dx. We do the same thing. So we have 6x to the power of 5 plus 1 divided by the new power, which is 5 plus 1 is 6. We do the same thing, 7 x to the power of 2 plus 1 divided by the new power, which is 3. Then again same thing, plus 2 x to the power of 0. Since it's 2 is by itself, it's 2x to the power of 0. So we add 1 to the power, so 0 plus 1 divided by the new power, which is 1. And then we get x to the power of 6 plus 7 over 3x cubed plus 2x. So now, eventually, as you practice, you can do you probably wouldn't have to write all of these down. You can straight away go into the steps. For example, 6x to the power of 5. We know if we quickly do it, it's like 5 plus 1 is 6, 6 divided by 6 is 1, and then all we remain with is x to the power of 6. So we can do that easily in our heads. So now, let us do more functions. So now, let us bring our concept of integration to trig functions. So if f of x is equal to sine x, when we differentiate that, that is basically cos x. When we differentiate cos x, we get minus sine x. Now, integration is the exact reverse. So if you have the integral of cos x, dx. We know that if you differentiate sine x, we get cos x. So if we go back, we then get sine x. Then if we want to integrate sine x, the derivative of cos x is minus sine x, right? So if we're only integrating sine x, the integral of sine x has to be minus cos x. Because think about it. If you have minus cos x, if you differentiate minus cos x, we get minus sine x. And the minuses cancel out and we get sine x's. So usually, once you have integrated something, you can check whether you have integrated something correctly by differentiating what you have integrated. So after you differentiate it, you can compare it to you can compare it to the original equation. Before I forget, we should always add the plus c. Like as you saw, I forgot, but that's very important. Whenever you integrate, especially without limits, you always have to add the plus c. So even for these questions, I forgot to add the plus c, but yeah, always ensure to add the plus c because the c is very important. There's always a mark for that plus c. Okay, so now we have like a general idea of how to integrate trig functions. So let us now go more into depth about those. So if we have f of x is equal to sine 2x, if we differentiate that, we get f dash x is equal to 2 sine 2x. Sorry, 2 cos 2x. Now, when you integrate, you do the same thing. So if I'm integrating, if I'm integrating cos 2x, we know that if you integrate cos, it becomes sine. So we have sine 2x. But one thing we should pay attention to is when we differentiated, we took our period, which was I think to the coefficient there, and we multiplied that. We took it out and multiplied. So now when you integrate, you do the reverse. This is where you take it out and divide. So you have cos 2x, it becomes sine 2x divided by 2. The same concept will apply to, like, suppose let me say integrating sine 3x. So we know integral of sine is minus cos. So this is equal to minus cos 3x. Then we take out the coefficient here, which is 3, and then we divide. Since when we differentiated, we multiplied, but in integration, we divide, since that's the opposite. So we put the divide by 3. Then always remember, don't forget the coefficient. Sorry, don't forget the constant. So in general, if we want to integrate a function f of sine ax plus b, what you do is you take the coefficient of x. You first integrate the sine. So in this case, integral of sine is minus cos. Then whatever you have here remains the same. So you get minus cos ax plus b. Then you divide by the coefficient, which was a in this case. So that's how you integrate a trig function in general. In our next session, we will extend our concept of integration to functions such as f of x is equal to 1 over x, and we'll also tackle definite integrals and areas under a curve. Okay, thank you guys for watching the video. Hopefully it was helpful, and see you guys later.